So far, we've been writing instructions once. But what if we want to do the same thing many times? I'm not just talking about 5 times. What if we want to do the same thing like 1,000 times? Want to do the same thing 100 times? How do we do that? Another scenario, imagine checking the temperature of 100 machines one by one. That would be tiring, right? So loops help us repeat tasks and automatically, right? That is our topic for today, loops. So we have for loops. That's one type of loop that we look at, and let me just write that down for us. Texts. Oh, I made a mistake there, and we're going to say we have loops over here. We have for loops as well as while loops. For loops and while loops. Oh, okay. Let me just put a comma there. I don't know why it's doing that. That's okay. While loops and for loops. That's what we are going to look at, right? So we're going to start simple, right? But then I have to introduce something for us to use this. And these are lists. We will get into detail with this, I think, in the next lesson or so. But we have to look at another data type that we have. And it's a list. A list contains many items that we have that are separated by a comma. It doesn't just contain one value, like what we did when we have age or when we're writing on text and all that. Those had one value, right? But what happens when you have a number of things that you want to be stored, right? In a variable, you can introduce a list. So a list, you could have something like, then you introduce and it what. So this could be your list, right? It could go on and on and on. You just add your commas and add that to that. But then this is a list. So this is what we have. This is a list. This list contains temperature values. So for lists, we can perform a number of operations on lists and all that. But for this one, I think I could actually show you some of the things that we can do with our lists. So let's have this. Like I mentioned, right? I said we have a list. Let's just call it X for the sake of this exercise. And we have what values? We're going to just put simple numbers there. 10, 20, 30, 40, 50. Right? Like this. And I was talking about something that I mentioned. I said that we have what we call indexing, right, in lists. So this is a list that we have here. When we talk about indexing, let's think of it as positioning. The positions that we talked about, something about having order, about how the items are ordered in here. So the collection of items is ordered. So we're going to look at something we call positioning, that's indexing. We have this item and we want to figure out what is its position here. We also have this one. This is the first, second, third, fourth item, fifth item, right? If we're saying it like that, it sounds a bit easy. Simple, just say, oh, that one, oh, that's not hard. This one is the first thing that we have. This one is the second thing that we have. But with indexing, you should not something. Indexing starts at 0. So that means this is position. This isn't position 1. It's the first item that we have in here, yes. But then this position is not called position 1. It's called index 0. So this one is index 0 over there. This is index 0. Then this is index 1. This is index 2. We have 3 and we have 4. Right? So these are the indices for this, right? For these values that we have here. And another one that we might just want to take note of, if you hear anyone referring to an index that has this position. So we say this is position 0, 1, going on and on and on. If you ever hear it, when someone says, oh, I want position, I want this index, we want this index -1. Or here, this is the last item. This is the last item in the list. So in this case, it will be, so here it will be what? It will be 50. Right? That's just something that you can take note of, right? In our list. So we are starting from 0. We're counting starting from 0. And if we're counting from the end, we start at -1. So that's something that we can note about lists. And if we want to look at other operations that we can do with lists, we can look at something interesting over here. We can use this. Let's say we want to add an item to this list, right? Our list, we said our list is X. So let me just move this there and let me get into this one. We have our X is our variable. X is that list over there. Let's say we want to add something to the list. We want to add it at the end. We want to add item at the end. So add, let's say we want to add 50. Add 100. Add 100. You want to add this value there. Add 100 at the end. Want to add it to the end of the list. We will use the dot append. Right? We're going to use this. We're going to write it like X dot. Let's just make this dot append. And then parenthesis. Then we're going to put the number that I want to add in there. Right? We're going to add it to that list there. And we shall put it in there. And then it's, we want to add 100 in there. We want to add 100 into our list there. So this is what we're going to have. So we can think of another way of adding items. And we want to insert, we might want to insert this 100 at a specific position. Let's put it at a specific position. Right? And let's say I want to put it at, which position would I want to put it at? Let's put it at position 2. I want to put it at position 2, right? At position 2. So position 2, like we said, right? Let me just move this. Sorry. This is 0, 1, 2. Want it to be here, right? This is where it will be. So it will push 3. These things will then go in this direction, and it will create space there for this value that I just have over here. So over here, I'll come in and say X. I'll use X dot insert. So with insert now, we have to specify the position where it's going, right? The index position where it's going. So over here I said 2. That's where I want to put it. And the value now, what value am I putting there? I'm putting 100, right? That's what you want to do there. So that's another operation that we can do. So we can do this one. There are a lot. I'm just introducing this, since I think since we're already talking about lists, it will be appropriate to introduce them at this stage. And then now let's say we want to remove a value from our list, right? We might want to remove by index, right? you might want to remove by the actual name, like, you know. So let's say I might say I want to remove, so I might say X, right? I might want to remove what numbers do you have? I want to remove the 10 there. I want to remove the 10 from there. So what I can use is I can use this syntax X dot remove, and then what is it? It's 10, right? I can use that, and I can remove it by index, like I mentioned. I can say X. For index we don't use this. For removing by index we don't use this, right? For by index we can use something different. Now we use something that we call del from delete, right? We can use delete. Wrong pen. We can use delete, del, delete, right? X. Then we have to know the position of this. What position is 10? Let me just check. It's position 0. So we come in and put so in here we have the index. Just like over here how we have the index. These are the index values that we have. So you'll find that there are a lot of operations that we can do. So let's just go back to our code space and see what else we can do over here with temp over here. Let me just try and regroup. All right, for here, let's actually try to do some of these here. So we can go by temp remove. Okay, yes, we want to remove that, right? And 503, we have that 503 there. Then after remove, we want to actually display what's now in the, we want to display what we now have. Oh, sorry, it's a capital temp right over here. Let's try to print it. You see, it has removed that. It has removed that from here. And let's try something else. Let's do the del. Delete. Ooh, it's supposed to be a code block. I made a mistake there. Alright. Delete that. We're going to add a code block. It's going to be del temp. So we said we want to specify want to remove the 10. Is it? So now remove the 10. Oh, sorry. The position is 0. Oh, I had to print that as well. It just ran and I didn't print it. So as you can see, okay, I ran this twice. That's a problem. So let me delete this, because you might be wondering what does she mean she moved it twice. So let me just do this. Remember when I pressed that run and then I was like, oh, I forgot to put print. Then I ran it again. So I removed the first position. The items are in the first position 2 times. But so that there is no confusion, let me do it again. Alright, so this is what we have in the list right now. 10, 20, 20, 60. And I want to remove what's in the first position. I run this. Oh, I keep removing items. I have to start here. Let's start with this one. Alright, so that we start again with a list that has no items that have been removed, right? Then we run this. Yes, you see, now it has removed the first item. We now have 20, 20, 60. Then when I run this again, I'm telling it to delete the thing that's in the first position. So in the first position, we now have this, right? Right? So if I run this, it should remove this 20 and we'll be left with 20 and 60. Let's do that. Just 20 and 60. Let me do it again. Let me tell it to remove the first item, remove this 20. We should have a 60 only. Yes. Then if we remove this now, we should have nothing in that. It should be an empty list. So that's what I meant when I was saying all that, right? So we do have other, let me just use a text file. This is what we have. We do have other methods we can use to update items. You can look at those. You can look at the length function to determine the length of the list. And you can also do sorting stuff in the list. You can use sort. Then you can do the reverse order of items. That's another thing. And all that. So these are items that we'll actually be using. So do look at this and just prepare for the coming lessons, because this is going to be very useful for us. So I just wanted to introduce them a bit before I got into the loop. I just realized I should have had a lesson on lists before that. Okay, so lists are very important. And now, what do we do when we have loops? So what's the advantage of having loops? You see what I did there when I was trying to delete items in the list? I had to run that a couple of times, I think 4 times, to remove a whole lot of things, right? So imagine if I had been told to remove the 1,000 items, that are in the first position, like one after the other. I would have pressed the run button like 1,000 times, and that would have been a lot. So loops let us process every item in the list automatically, right? We don't have to do that by ourselves, right? So we are going to introduce the for loop first. These operations might feel small, but when you start working with datasets that have hundreds of machines or thousands of rows, knowing how to add, remove, and update items efficiently becomes crucial, right? Lists are foundational in Python for organizing your data, and you use them all the time when working with AI datasets. That's why I was saying that we should look at these updating items, length, sort, reverse, all those functions. You should be comfortable with them, since this is the foundation of what we're going to be doing. So let me look at the temperature list again. Let me run this. I'm running this one. I ran this one now, and this is my current one. I'm not running this now, so that I just want to have temp as it is, right? I want temp without being tempered with. The temperature one, print tab. Let's see what this one does. I'm appending 100. I'm adding 100 to it. So this is what we have. This is what we have in our temperature. In our temperature list, our temp list, right? So what do I want it to do? So we're going to introduce a simple for loop. What does the for loop do for us? All right. So this is the syntax. For x in temp, do something. This is what we do. So for item, for x over here, so x, you can write it as x, you can write item, you can write anything you want to write here, it doesn't matter. So what it does is saying for item in temperature, for every item that we have, for everything that we have in here, right? That's what the syntax means. And then we put a semicolon. After the semicolon, we tab inside, we indent, because we want to perform something according to that condition that we have for something in x. for something in temperature, we want to print that something. We want to print it. So for item in X, for item in temperature, for every item in temperature, what do we want to do for every item? We want to print it. We want to print that item. So what it does, the four syntax that we have here, it will start the loop, right? And item will be like a temporary variable. So it will store one value at a time. So for item will be each and every value here, one at a time. And then it will take, where is it taking the items that it will store? Is it taking them from this list? So it will loop through this list. It will go through this list, it will go through 10, then 20, then this and this and that. So for over here, what we want to do, this is very simple. We're not doing a lot of things. We just want to print the items. So it's going to come in here in this list and say for item in list. So item will be equal to 10, the first round. Then it will be equal to item here. And it will be 10. Then after that, it will come back in here and we'll check at 20. Sorry. And if you do that and to everything, it is looped through everything in the list. So let's just check what we mean over here. And this is what it does. So as you can see, for item in temperature, it comes here and prints the item. So it will come here and print 10, then 20, then 20, then 60, then 100. This is what we have. This is what we have for the for loop over there. And we can add a condition. So how do we add a condition? Let me do it over there. We can say for item in temperature, let's say that it will look at every temperature and to check if it's above 30. If it's above 30, it will print it. That's when it will print it, right? So temp, and then I'm going to add my condition here. If, so it's a condition that's inside the for loop. If item is greater than 30, I want it to do something. I want it to print this. It should print I want it to print temperature high. Temp is high. And then it will give me the value of the temperature, right? So I want it to print that temperature. Let me go there. Why is it not? Oh, okay. It has moved. I was getting confused there. So it'll print the temperature. That temperature. So it will write this statement. Then it will also print the temperature. Print temperature is high. Then if else, what will it do? Else, what will it do? We want it to do nothing. If it's not above 20, if it's not above 30, we want it to print anything, right? But let me just add the other condition, right? Else, if it's else, that means if it's less than or equal to 30, it will print temperature is low temp. Right? Because the temperature that we want, probably the temperature that we want in this case would be a 30 or whatever. But if that was the case, I would have had to put, so let me put if it's greater than or equal to the, so that we cover everything. Yeah. So if it's high, then if it's less than that, it's low. Item. And then over here, we did forget a comma. This and then this. Oh, sorry. Look, I said we can use it with a condition, and then there are so many other ways it can be used in other situations, complex problems, and all that. So now I want us to look at a while loop. So what is it with the while loop? So a while loop now repeats as long as a condition is true. So it'll keep repeating it, you know. So what we have to make sure, right? We always have to make sure that something is changing inside the while loop so that it stops. Otherwise, it will continue running and running and running and running until you actually just have to stop Google Live or just get away from the page, because it won't stop executing because of, you know, or unless you break it, right? It will continue repeating as long as the condition is true. So you have to just make sure that something is changing within the while loop, right? So let me just go to our drawing area so that we can look at this. Sorry, there's a lot of things going on. So this is where people might use a counter or counting to just make sure that something is changing. Maybe it's counting the number of times it's doing a certain thing until it has reached a certain condition. So it makes sure that a counter is changing and all that. So we might have something like this. Let's look at runtime. We might have our runtime. These are ours, right? For runtime, we have them being equal to something. So this could be a counter. So we have 0 hours to begin with, right? So we have 0 hours. That's the beginning. That's the beginning that we are going to begin with. We have 0 hours, and then what we want to do is we want our machine to run for 5 hours. So we want it to run for 5 hours, and we want it to run for 5 hours over there. We want it to run for 5 hours. These are hours. So it will be at 0, 1. So it will have, we have 0, 1, 2, 3, 4, 5. These are the hours that we want it to run for, right? And there. So we want this runtime to be sort of our counter. We want it to count. We want it to increment by 1 after the hour, right? To increment by 1, the value increment by 1, and it might not just be hours really. It might just be a counter. In counter, I want to increment it by 2, by 3, by 4, by 5. We're incrementing by 1, until it reaches 5. That's what we have. But if it's below 5 hours, we want it to continue running, right? It will only stop. It will stop at 5. This is where it will stop. It will start. Okay? And in between, it will run. We want it to run. So our condition for this problem is that while the runtime counter, the runtime, this one is less than 5. This is just on a higher level. There are maybe bits and details that do need to be added for it to make more sense. But for this part that we have here, this looks like an L. Okay. Okay. Let me go there if you want it. Alright. While runtime is less than 5 hours, we want it to continue running, right? Want to continue running, and we want it to. So what you can do while the runtime is less than 5, it can print. Can tell us what the runtime is. The current runtime is print runtime, right? And our current runtime, we said we have our runtime at 0. That's where it's starting at, right? We have initialized it as runtime. This is where we initialize it. This is where we're starting. It's important to initialize because we want to know where we were starting. So it will initially print 0, right? This is what the while loop will do. It initially prints 0. But what we say, we want something to be changing within our loop. Something has to change. And what we can change is the runtime. So after it prints runtime, here it prints 0. You want our runtime to increment by run. Oh, I wrote runtime. Okay. You want our runtime to increment by 1. And what did we say the shortcut for that was? We write the plus equals 1. So it has incremented there, right? By 1. So this could be our code block over here. Let's just let me just push this over here, and let's just have a border so that our work is at least readable there. So this is number 1. We initialize 1. We set there. Then we come in, introduce our while loop. Then this is the first thing that we do inside the while loop. Number 3, we print runtime. After printing the runtime, we increment the runtime 1. It's now 2. And what happens after this? Our loop, it will now loop. Where will it loop? It will go from there. So it will go from number 4 to number 2. This is not inside the loop. This is only executed once. Then this is the part that's executed more than once. So here, until the condition is met, right? So it will then increment. So let's try to write this down so that we understand. This is the first time we're doing it. We have 0. Our runtime is less than 5. Is it less than 5? Yes. It goes here. It prints the runtime. The runtime is 0. Then it will then come in and increment our runtime. Our runtime is now 1. It will come in and check what is the runtime. It's 1. Is it less than 5? Yes. To print the runtime. To print 1. 1. We increment the runtime by 1. It's now 2. Is the runtime, it will come back here, it will come back in. So like I said, it will come in here, it will check 2. What's happening with the 2? Is the 2 less than 5? Yes, 2 is less than 5. Then we'll come in and print the runtime. We now have 2 there being printed. Then after printing 2, it will come in and increment by 1. 2 is now 3. Then it will move back and loop again 3. Then we now check 3 is less than 5. Yes, we print it there. 3 is printed. Then we increment 3 by 1. So 4 comes in and checks 4 is it less than 5. Yes, we print that. It goes here and prints 4. 4 incremented by 5. Yes. Then it comes here. Is 5 less than 5? No. So then it breaks. So here we got the breaks over here. This is what happens. So this is what it will do for us, and this is how it works. So condition is checked every time. If you forget to update the variable, your variable runtime, it will loop infinitely. Yes, so that's what we don't want. So when do we actually use the while loop? So we can use this for when we know how many items you have. You remember for the for loop, it was going through items. It didn't know how many items are in the list. It was just going through every item in the list, right? But again, let's say you know the number of items that you have, number of items you want to loop through. You can use this, and you can also use this when you don't know when to stop. Like, you're not quite sure where you want to stop, where you're supposed to stop in the list of things that you have or whatever, but you just know maybe the condition you want to stop when this happens or whatever. It will take care of that. So this is where you can use it, right? Then now let me move back to our code and go there, and then we're gonna comment this and write while loop there. Then I'm going to come in and write the code, right? The code is exactly how you're writing it there. So it's going to be while our condition. I didn't initialize runtime. The first thing is to initialize runtime, which is going to be our more of like the counter for us. Runtime is going to start at 0. We wanted to start at 0 here. It's going to start at 0. So while runtime is less than 5, then it's going to print run, then runtime is going to increment it by 1 every time. Then it will print run. Okay, let's not print run. I want it to, okay, let it print runtime number. This is why we don't like these suggestions. They might be wrong, but most of the times they do give us a correct direction. So let's say runtime number, then come in like you learned from that error previously. Sorry. Oh, my battery is low. And then we're gonna come in and write runtime, so that, okay, what's happening there? All right, runtime number 0, 1, 2, 3, 4, 5, just like we predicted, and it breaks. We didn't predict, really. That's like we worked it out. That was just working it out. And this is what we have. So thank you, and these are our while and for loops.